liftoff of Space Shuttle Atlantis.
Space, the final frontier, the home of all the unknown. It's fun to imagine that while we are already exploring space, we still don't know a lot about it. I mean, we don't even know our own oceans to the fullest yet, but we're already exploring space and shooting for Mars. And in this video, we'll be shooting past Mars, into the unbelievably big universe. All the stars that inhabit it, the planets that follow them, and all the theories about what might be happening out there. And quantum mechanics, which I just really hate. Again, while we have documented a lot of things in space, most we have not, and can be seen as a kind of wall of mystery which we can't understand. Is it as dangerous as you think? Does it have a greater purpose? Is it even real? All of these questions will be asked, studied, and maybe answered. I mean, I am no scientist, not by a long shot, so don't expect me to answer the questions not even the big brains in our world can understand. But hear about them we shall, and learn about the deepest secrets that infinite space has to offer is what we are about to do. So look outside at the starry night and prepare yourself for impact, as we're about to dive into the iceberg chart of space and all its mysteries. And the first stop on our great journey is the sun. No, Philip, we're going the wrong way. We can't land on the sun. Philip! Nah, but for real, the sun is most likely the one thing you know most about space. I mean, you see it on a daily basis, unless you're a basement dweller or live in Scandinavia. There's a bunch of things to know about the sun, like how it actually functions. It produces 3.8 times 10 to the power of 26 joules of energy per second, which is about 1,000,000 times more than we used in 2013. Again, in 2016, we used 1,000,000 times less energy than the sun did just now. Just imagine the amount of power that actually is. The sun is a giant ball of nuclear fusion, and is made of fire in the middle of space. It doesn't even care. Even just the fact that it can light up our days from that distance that brightly is in itself impressive. Despite it being a simple fact of life, the sun is very fascinating. There's a reason why it's been worshipped for millennia. Humanity's greatest quest, finding a friend. The search of life in space is in fact older than our space journey itself. Books from the past have actually thought about how an alien race might look, behave, and act. Because are we really the only ones in space? And that isn't just intelligent life, that is any life at all. Some bacteria on the wall, great, we'll take it. But it seems, in this huge universe with 70 quintillion planets which might bear life, we are the only ones. And how is that? Some use the rare Earth theory, which states that living or even intelligent life is so extremely rare that we might as well just be the only ones for an extremely huge amount of distance. Others will say that a civilization has already gone so far in advancement that they're actually casing us in to protect themselves. You know, just in case. Others use a great filter theory, which says that civilization cannot pass through a certain stage of advancement without dying. From asteroids to sun blowing up, war, nuclear war, natural wipeout, or anything else. And in the end, as we stand currently, we are just alone. Yuri Gagarin is a man that will forever be placed in the history books, because he was the first of our kind to travel in space for a whole hour and 48 minutes. Some might call it the biggest achievement in Soviet space history. During the Vostok 1 mission, Gagarin flew a whole leap around the Earth, just above the upper atmosphere, where they experimented on how to get people up and down again from space. They had long tested on different kinds of space capsules, using dolls that alike to prepare them for real space. This was, after all, during the space race, where the USSR and the USA tried their hardest to gain an advantage over the other in space technology, and sending the first man into space would be a huge victory. And it was. Gagarin was seen as a worldwide hero, and the Soviet Union looked superior in space technology once again. However, despite this huge win and many others, people still see the moon landing as being the only real goal and the reason why the US won it. A very debatable debate. Constellations are a group or pattern of stars visible from Earth which resemble some kind of object, animal, or god. In the modern day, there are some 88 accepted constellations in our night skies, which doesn't really tell us much. In actual space, they don't have that big of a role. They are simply what we are seeing from Earth. A few bright dots on an otherwise blank canvas of black sky. And while it is a whole field of study and has been used since ancient times, both to determine the future, explain how gods exist, tales are real, and who will win a land dispute, thanks Babylonia, it is, after all, just about thinking about dots. Yes, little Timmy, our great sun will one day explode, but don't be sad about it, my friend. You see, that explosion will happen some 7 billion years from now, and will we be alive by then? No. But in all fairness, if we are still only on Earth some 7 to 8 billion years from now, and haven't gone out to explore and colonize the universe, then perhaps we deserve to die. I mean, we began last century, and we're still stuck on here in 7 billion years from now? Then what the fuck? But again, we might all just be dead by then, and I mean, all of us. Also, just before exploding, the sun would decrease in size, energy, and heat, which would create a real simple winter on Earth, freezing everyone and everything on Earth before exploding. And along with that, it would also increase in size before then and swallow the Earth whole. And even by then, it would become so giant and hot they would just burn Earth. So, no matter what, we would die in many different ways before then. So good news, Tim, we are not dying. We are going to live forever. Exoplanets, just clean and simple, are planets that circle around other stars than our own. So exoplanets are just other planets. There are many of them, as you know. The search and research of exoplanets might be one of the most important tasks we have at hand when it comes to understanding outer space. It is here we might find life, a future home, strange phenomena, or just more clues about the big puzzle of space. While the search of exoplanets started quite slowly, already back in the 1800s with false claims here and there, the first real exoplanet was picked up in 1988. And since then, we perfected the art of finding other planets to a point where we will always find more than we did last year, by a huge margin. We have reached about some 5,000 at the time I write this script, and it is only increasing. Simply look at a star, and when the amount of light emitted from the said star dwindles for a moment, then that might just be one of its planets moving in front of it, making a light curve. Now if this continues for a set amount of time, like how we rotate around our star a set amount of time, then we are talking about an exoplanet. Now these exoplanets are inhabitable by default. Far from actually. The only one we're certain about is Earth, and that is a boring answer. They have to follow a certain amount of criteria, like being in the habitable zone, have water and atmosphere, be made of rock, and a lot of other things. While we do have some candidates, some even being quite close, at the current rate, searching for exoplanets seems to be nothing more than just rock collecting for astronomers. When understanding how things circle around each other in space, the answer is pretty simple. There is one big thing in the middle, which the small things around it circle around, since a huge gravitational pull from the big thing affects the small masses. You know, like our solar system, pretty much. It seems to be the same with galaxies. Many small solar system and gases that circle around the center. Now what's in there? Well, in the modern day, scientists are pretty certain that it's a supermassive black hole, having the ability to keep the whole galaxy moving and make it fit together. However, we can't actually see this black hole since there's a bunch of gas and dust in the way. So we use gamma rays, X-rays, infrared light, sub-millimeter, and radio wavelengths to try to understand what's going on in there. Since we can't actually see the middle of our galaxy, a bunch of theories have begun to spring up about it, from ancient times to the modern day. One even saying it was a giant sun in the middle, but all of these have been debunked pretty much. This trend of having a supermassive black hole in the middle seems to be kind of common, as other galaxies also have this massive hole in the middle. But who knows, maybe out there, someplace, a strange galaxy exists which has something else in the middle. 13.7 billion years, now goodbye. Okay, we can milk this a bit more. By using all the resources we have, and generous research and double checks, we have concluded that the universe is around the 13.7 billion years old, with a gap of error of some 200,000 years. Now you could go biblical and say it's only some 6,000 years old, since that would be around the time God made, well, everything. Or you could listen to Vedas, the sacred book of Hindus, and claim it is some 311.4 trillion years old. But if we go back to the theory that is canon in the scientific community, even that is quite uncertain. While a lot of people do believe that the Big Bang happened around this time period, we have also found galaxies, stars, and planets which seems to be even older than that, which either means that someone calculated wrong, or that the Big Bang just never happened. While it is believed that some of these errors might have come from problems with the Hubble telescope, and that we are getting more and more certain about the number 13.7 billion, there still have been a lot of errors in the past, leading to the cosmic age problem, or we aren't totally certain yet. But again, as it seems, we're going on the right track. While supernovas, the explosion of stars, is a rather new thing, only being caught in 1929, there have been a plethora of supernovas discovered throughout time. The oldest one is SN 185, being discovered in 185 AD in China and maybe even in Rome, where a bright star appeared and lit up the night sky for 8 whole months before vanishing once again. It sparkled like a star and moved across the sky like a comet. Another one is SN 1006 from the age 1006, which was apparently the brightest star to ever shine on Earth in recorded history, being documented pretty much everywhere from Switzerland, China, France, Egypt, everywhere. Or the supernova 1572, which was discovered in 1572. Yes, good, you're learning. Good going. Fucking Dora the Explorer moment. It was discovered by my guy Tycho Brahe, and apparently only him, as he slowly studied the night sky from Vin Island, documenting the entire thing and documenting it as a newborn star. And then Sweden took the island. Sadness. Basically, all these supernovas have been seen time and time again, popping up at random, but after we would discover them, admire their beauty, and then write them down. The Kuiper Belt is an asteroid belt in the outer part of our solar system, made mainly of ice and comets. It is a bit different from the other belts in our solar system. Not only does it have a more of a donut shape and isn't an asteroid belt, which is also in our solar system, it also houses several microplanets and moons. Even Pluto can be found in there. Despite us knowing what it is, mostly, it is still filled with mysteries. We don't know all the things that can be found in there, since there's so much of it. I mean, we easily could, but it'll take time. But that still leaves the question of what might be in there. We've already found so-called dwarf planets like Pluto, Planet X, moons, so who knows what might be in there. Of course, there's no life in there, it is just ice, comets, and rocks, so, hey, cool rock collections, I guess. The Fermi paradox is a thought I think most have thought about when it comes to researching extraterrestrial life. However, the paradox was coined in 1950 as the physicists Edward Teller, Herbert York, Emil Konopinski, and Enrico Fermi were walking to lunch together. They were talking about some recent UFO reports and faster-than-light travel when they came in at a topic of life in outer space, where they began to question the logic of how in the world there haven't been outer life on this Earth yet. Here is a general train of thought in the paradox. There are billions of stars in the Milky Way similar to the Sun. With high chance, some of these stars have an Earth-like planet in the habitable zone. Many of these stars, and therefore also the planets, are much older than the Sun. If the Earth is typical, some may already have developed intelligent life like our planet has. Some of these civilizations may have developed interstellar travel, a step we are developing right now. And even though it's going kind of slowly, we would have traversed the Milky Way completely in a few million years. Since many of these sun-like stars are billions of years older than the Sun, the Earth should already have been visited by these civilizations, if not their probes. Yet they aren't here and never have been here. So what's going on? Are we really alone around here, or is interstellar travel just impossible? Logically, we should have been colonized if anything at this point, but there is no one here. And we can't find anyone either, so perhaps we are alone? And that is why it's a paradox. It doesn't make any logical sense. A corned beef sandwich is a sandwich consisting of corned beef, perhaps some cheese, some pickles, and a bit of mustard if you're feeling a bit spicy. What? Space? Nah, it's my lunch break. Come on, give me a break, man. I mean, you think making these videos are easy? Gotta munch my lunch over here, Jesus. Nah. Well, yeah, but no. It's actually a thing that happened. Let me explain. The first ever official lunch item and the first corned beef sandwich to orbit the Earth was documented on March 23rd, 1965, when the NASA pilot John Young had smuggled it onto his spaceflight by putting it in his spacesuit pocket before liftoff, where it was going on the first ever two-man crew spaceflight in American history. He took it out mid-flight to eat, where the co-pilot, Gus Grissom, began to question how the sandwich got on board. This led to a long conversation about why in the world he took it with him in the first place, how it tasted, and how the crumbs were getting everywhere. It wasn't really that much, just a man eating a sandwich while working. But the politicians in America went furious. They called it the $30 million sandwich and cried out about the danger of the crumbs getting in his eye. This was most likely the Americans coping over the fact they were being behind the Soviets in the space race, since the Soviets had done the exact same flight 1 week before the Americans. As you can hear, this isn't the most deep, mysterious, or important thing to ever happen in space. It is literally just a sandwich an American ate. When you think of a moonwalk where humans try to explore the moon, you usually don't think of it as being that dangerous. I mean, yeah, you are on a different universal body that nature didn't want you to be in the first place, but besides that, it's just empty space. However, the moon dust on the moon is actually highly dangerous. How? Well, apparently it's straight up toxic and can destroy your lungs and brain cells. Every person who ever walked on the moon have gotten lunar hay fever, where they feel unwell and have a runny nose, apparently because of space dust. Not only is it made of silicate, which is the same found in coal mines, it is also 50 times smaller than hair, and then combined with the lower gravity on the moon, then it has a really easy way of getting into your lungs where problems can occur. While this might not pose a threat to humanity on our moon adventures, it will make constant settlement slightly annoying, because dust up there is just a bit dangerous. We can conquer dust, I think. Yeah, totally, why not? Oh wow, this low? What a signal to give. What a price to pay. The wow signal was a pretty big deal at the time, and still is to some degree today, since this 72-second long event showed a radio wave, seemingly from the Sagittarius constellation, which was unlike anything ever seen before. The signal seems too strong to have been caused by anything from space, besides extraterrestrial life. It was discovered in the Ohio State University by Jerry R. Ehrman, who got so excited by the result that he encircled the outprint and wrote "wow" by the side of it. The source traveled at a speed of 10 kilometers a second, and apparently came from space. Such a wave could only be caused by something serious, but what that might be is unknown. Also, don't trust the clickbait titles, they're all fake, so get them out of there. It's gone, whoosh, hey. Some claim a distant sun might have shut off the radio wave, some think it was an actual nearby microwave, and a certain Paris from St. Petersburg University in Florida claimed it was an asteroid. Yet that last one has been proven wrong by the Ohio State University. You know, the one who picked up the signal, as it was impossible, so shut up about the fucking asteroid. Or maybe we really are talking about our first ever contact with outer-worldly life, and in that case, we have shot out a response in the same direction the signal came from to try and contact the perhaps outer-worldly life. And what do we send to them? Twitter. And that is why they haven't responded yet. Why would anyone, let alone aliens, respond to Twitter users? The Mir space station was a Soviet and later Russian space station, which will go down in the history books as a station that taught humans how to survive and live in a space-like environment, but also as a highly troubling and fail-ridden experiment for the cosmonauts on board. It had a bunch of incidents, some almost even destroying the station. One time in 1988 when an Afghan cosmonaut was visiting, and yes, Afghanistan had a space program, the visit went horribly wrong as a spacecraft leaving the station made the whole station spin around in a way which might have caused damage to the ship. However, it was stopped before that could even happen. In 1999, when 2 cosmonauts had to return to Earth, the Soyuz spacecraft malfunctioned and had to be prepared before returning. Twice. How? Well, apparently, Soloviev and Balandian, the 2 cosmonauts about to return home, went out to fix it after watching a brief tape on how to do it. So, did they fix it? Well, not really, actually. They just kind of flew out anyways and somehow returned safely without even causing further damage. Another time, when a cargo ship had to dock in the Mir space station, the ship apparently went too fast for the station and almost collided with the station, only missing by a few meters. Another time, just fire. Just literally a fire in space. You cannot get more wrong than that. And that is but a few times the Mir space station could have gone horribly wrong. Yet, it did not. It lived out its entire life, taught us well, and crashed down onto Earth in 2001, near New Zealand, as expected. There have apparently been up to 2 astronauts in space, which are of a homosexual nature, that being Sally Ride and Anne McClain, and that's about that. I mean, I don't know what to say here. I mean, that's just the entire thing. However, we could talk about the fact that some articles claim that there's been too few homosexuals in space, or just generally LGBTQ plus people in space, but really, who cares about that, right? I mean, it's science, not politics. Who cares if it's Americans, or Russians, or Danes, or homosexuals, or straight people? I mean, as long as science is getting done, then who cares who does it, right? Man, this little bit just sucks ass, never mind. Now, this might be another the sun will explode scenario. On one hand, yes, the rings are disappearing. They're made of ice and rock, and despite being in the cold vacuum of space, the ice is apparently slowly losing its battle to the sun's warmth, and the rocks slowly losing their fight to gravity. On the other hand, it is said to be like in 10 or 100 million years from now, so don't get your hopes up. Or down, I guess. The loss of these rings will be a real loss for nature and our look at nature. Saturn's rings are like no others, which gives us a view into how nature always can be different in different ways. But again, humanity might be dead by then, so stop bitching in my fucking kitchen. Okay, so now we're reaching the bit more hard to understand sciencey bits. It gets a bit hard. Well, at least for the history student like me, I don't know science. Basically, when understanding how space-time works, which is just how things move and work in space, we have to understand not only how space works, but the space of space, which is in 4D. Maybe. Again, space is filled with theories, which might be true or not, and currently, we just don't know. So this is a guess, a theory, if you will. Now, we are in 3D. All you see has 3 dimensions, up and down, left and right, forward and backwards. It is as basic as it gets. Yet in space-time, which people have theorized might be in 4D, an extra dimension is added, that being t. T for time. Using time as a dimension, we try to ignore the thought that time adheres to common sense. Time will always move at the same rate. It simply doesn't change. A second will always be a second, no matter where you are in space. However, some might say, as also studied the 4D theory says, that this is a lie, actually trumping what Newton said about time. Imagining t as a measurement in space, one tries to remember that time isn't a thing in a normal 3D system. it just happens. Here, we are also adding how time moves. For example, time in space-time is basically that time has an effect on how things move, or vice versa. Meaning that when things go around in space-time, then time is another factor which must be calculated, because since it isn't set in stone, and the thing moving acts as an effect on time itself, which again, we don't need to worry about in 3D, but in 4D with time has something of an effect when things are moving. Yeah, I don't even know what I'm saying myself. If there are any sciencey boys out there watching this video, for the love of science, explain this for me, alright? I mean, even Wikipedia couldn't help me. But to try and grossly simplify and butcher this, space-time might have to be measured with time as a factor in the dimensions, instead of just a thing that happens always. dt squared also has to have a role in understanding ds squared when it comes to space. Space blindness, or impairment, is a phenomenon most astronauts experience sometime in their space life. Basically, as astronauts spend months on the ISS, other space stations, or even like the Moon or even Mars in the future, they seem to have pain in their eyes, trouble reading basic things, and need to rest their eyes for longer periods of time. While we don't know exactly why being in space makes you just a bit more blind, a common theory is that low gravity, or even zero gravity, increases the fluid in your body. I mean, it does, but usually that isn't really a problem at all. However, while most of the body will remain the same after this, the back of the eyes might experience pressure from this, which might slightly damage them, causing problems with sight. This might be a problem of the future though, because while some 6 months in space wouldn't do too much damage, if you have to send a whole colony to Mars, which will have to live there for years, then we must find some way to protect their eyes, because we don't want people to go blind on Mars. Potentially alone, so we must find a solution somehow. The Oumuamua spaceship conspiracy theory surrounds a meteor that flew through our solar system in 2017, which was highly unusual. For starters, it was found by the University of Hawaii, which named it Oumuamua, which is Hawaiian for scout. And that is because the asteroid comes from another star, which is the first of its kind we've seen in our solar system, so the name is kind of poetic. This meteor is, as I said before, kind of strange. It's shaped like a cigar, or shit, but let's just say it's a cigar, and it's arriving at a very high velocity, entirely escaping the gravitational pull of the sun. It also seems to speed up after passing the sun, which can happen because of trapped gas which gets heated from the sun, but still rather rare to actually happen. Along with that, the cigar shape and its tumbling around in space means that it must be made of some rather solid rock or even metal, to not split up in a million pieces. So the asteroid is very unusual, so maybe it's aliens. Wait, why are you leaving? Come back. Because this asteroid is so peculiar and comes from another star, then maybe it was alien-made. For some reason. Some say it might be a spaceship cruising through space, which begs the question, what the hell is it doing? But maybe I should ask myself, what the hell am I doing? Of course it isn't that fucking spaceship. That would be the most wackiest of all space events. It wouldn't make any sense at all. No, go home. Hawaii, you're drunk. So, string theory is, according to data Wikipedia, the theory of quantum gravity, and molecules smaller than neutrons. String theory is a theory that tries to be a theory of everything, a theory that would answer many of the questions we have about the universe's functions. And we aren't even sure if it's actually true. This could potentially be spitting bullshit. Well, I'm about to be spitting bullshit because I'm about to try and explain string theory.
1 hour later.
Okay, fuck. So, string theory is useful because it kind of acts as a foundation for quantum physics, which can fuck off for now. But by understanding string theory, we can use quantum physics as a real theory, and it can help a lot in understanding, well, damn near everything. Of course, the basis of string theory can be found in strings, which are either open or closed, depending on which type of string theory you practice. Yeah, there are more of them. All the different string theories have a different way of explaining these particle strings, which might act like a normal particle, but are in fact strings of different kinds, all acting like particles, but aren't particles. All 5 string theories put together with 11D supergravity, which I'm also not gonna be bothered with M theory, which combines them all, might make it all possible. By making all of these theories possible, then it can be confirmed that these particle strings correspond with gravity, which in return makes gravitational force a thing in quantum mechanics, which then in return can make it into a theory of everything. It is a super complicated mess which tries to advocate for strings in our universe, which acts as a foundation for gravity in quantum mechanics, if anything I said is even real. Again, it's a theory that tries to make a foundation for quantum mechanics, which in return will make a foundation for understanding the universe's many questions. But again, it's a theory. It might as well just be magic in the end. This is a subject which could be very tough and in-depth, but I'm just not gonna go down there again. I mean, we all know what this is. This is a theory that there are multiple worlds out there, all with different outcomes, even if just insignificant. It doesn't make any sense, but that's the thing about quantum. It doesn't use common sense, which might also be why I hate it. Basically, we can see the MWI theory as a forever growing tree, where one event becomes 2, which becomes 4, which becomes 8, as options are shown. Using Schrödinger's cat as an example, but times 3 and with Brezhnev. By the first box, Brezhnev can either be dead or alive.
Всем вам здоровья.
Shut up. If you open it and he is alive, then that is one outcome. Is he dead? Then the KGB will kill me and hide the body, but it'll also be another outcome. Now, these can happen at the same time, but they could, which is where the 2 universes come into play, where the possibility have to be there, so one and the other happens in these 2 worlds, respectively. Then if we do it again, then he might be dead or alive again, which makes 2 universes into the 2 that have already been made. That is 4, do it again, 8, and that is how it goes on. Well, not really, because once you die, you are dead, so you can't die again, so here we are. One can imagine that if even irrelevant things can make another world split from one another, how many worlds there might be? Some where everything is totally different to one where you didn't stub your toe this morning. I think. Again, it's a theory, so shut up. Existentialism at its finest. The Boltzmann brain is a philosophical and scientific paradox which claims that since some things can be made from nothing, then single brains or minds which thinks it is a common, sentient being or thing, could form in voids where there is nothing at all, using thermodynamics and random fluctuation. Yeah, it's a mouthful, but it makes sense. Basically, nothingness could have consciousness. According to the paradox, it is actually more likely that a single-brained organism forms in a void than the entire universe just appearing in the Big Bang. Now, this has been cited as an unprovable theory, aka it cannot be proven false or correct, so take it with a pinch of salt. But if the Boltzmann brains are real, that would mean that there are beings out there which do not exist, yet they think they exist. Perhaps even you. What if you didn't exist and all you see is simply what your brain tells you? What if you were a conscious blob of nothingness, all your friends, visions, and truths being nothing but nothingness becoming somethingness? Your brain being made from the smallest points of beings in this universe. While I can't prove that you are one, I also can't disprove it. To understand the merging of fundamental forces, we must first understand what fundamental forces are. There are forces which must appear to make basic interactions work, and are some very important and, well, fundamental forces that makes the whole universe work, like gravitational, electromagnetism, strong forces, and weak forces. There might be more, but we haven't found them yet. Now, some people have theorized that it wasn't always like this, that there was at one point when all these forces were united into one big force. That might have been in the very early years of the universe, when everything was extremely hot, where the four forces were united as one, but when it got colder, it began to split off because of spontaneous symmetry breaking. That's the thing. And with that being said, what if we reunited these forces? Could we possibly merge the fundamental forces into a superforce? A united force? Well, we don't really know because, we haven't been able to do it yet. It's kinda hard to merge the laws of physics, but still, who knows how such a force would work? How would gravity, electromagnetism, and strong and weak interactions work together? Would it just be a giant magnet, or would it just be a giant gravitational pull? We don't know. That's... wow. That is quite mind-boggling. Man, I love science. So, dark flow is not only a great band name, but is also a term used for the peculiar velocity of galaxy clusters moving towards a patch of sky, which might be another component acting a lot like dark matter and dark energy, if it even is real. Does anything even exist in science? Is it just like one big theory? As it seems, there are currently hundreds of galaxy clusters moving about 2 million miles per hour towards a certain patch of sky between Centaurus and Hydra. In reality, these clusters should be moving about all willy-nilly at random, all over the place, but for some reason, they're all moving towards this random place in space. Therefore, a hidden force might be in play, a dark flow which dictates where certain things move. We know nothing of it, but it might be a bigger player than we might first have thought. But a lot of scientists are pretty skeptical about this, and some even deny it being real, so what the fuck are we doing? Say, kid, you wanna become God? Well, by the use of quantum physics, this might just be possible. No, I'm not kidding, quantum theory might just be able to make a person immortal. You see, Schrödinger's Brezhnev is a good way to explain this. I have told it before, and you most likely know what it tries to explain. If I switch the switch, there are 50% chance that Brezhnev dies and 50% chance that Brezhnev survives. Shut up. Which, of course, is where two worlds split up. They're the exact same, yet in one he survives and in one he doesn't. Now, if MWI theory is true, that means that there will always be a universe where Brezhnev dies and one where he survives. Now let's focus on the last one. There will always be a universe where Brezhnev survives. If that theory is correct, then that means that there always has to be a universe where Brezhnev survives, which means that there must be a universe out there where Brezhnev is unkillable. No matter how many times he's put in a life or death situation or in a Schrödinger's box, he will survive in this universe, no matter what. This is quantum immortality, and there is theoretically a universe where all of us are unkillable. Every situation where we have the chance of dying, we will survive. Now, if this extends to old age, it's not really well known and might be a bit far-reaching for this bit. But still, if quantum physics do work and are real, that means that you might just be unkillable. But, that also means that by use of quantum mechanics, quantum suicide is also real, which is the universe where you must die in every single life or death situation you're put in. So you are probably in like the middle somewhere. Now, we all know what electrons are, right? 2 seconds. Yes, we all know this. Now, many different atoms in the world have different amounts of electrons. From simply one to many. And while they are the same kind of being, an electron, there is also a lot of them in the world. Or are there? What if I told you that in the entire galaxy, the entire everything, in the entirety of you, there is only one electron in existence? What? No, I'm still sane. But these spray can fumes are good though. This theory was first thought up by John Archibald Wheeler, who used math, quantum mechanics, and a bit of thinking to come up with the theory that electrons, or, well, electron, travels both back in time and ahead in time continuously, meaning that it can be in many places at once. This theory explains why all electrons weigh the same and work the same. It would also help quantum theory become real. They're all the same, but again, most likely not. I mean, really? A single time-traveling electron? I know it's quantum physics and all, but there must be a limit somewhere, right? This theory, for example, doesn't explain how more electrons are made or how some vanish. There should, in theory, always be as many back-traveling electrons, called positrons, as there are forward-traveling electrons. But there isn't, so it might just be more guesswork. Now, we all know what a vacuum is. It is when a certain area of space experiences as little energy as possible in said area, where it has nothing but a quantum field, because fuck knows. It is a quite normal thing in science, and especially in space. Yet what if we bring a false vacuum into play? What would that even be? Well, while a vacuum is stable, a false vacuum is not stable, only reaching a local minimum, as this graph shows. You see, that is an all-time low. That is a local low. Well, anyways, what does that really mean? Well, if you look under the part called existential threat, then I might explain a bit. Basically, if we are in a false vacuum state rather than a true vacuum state, then the decay from one to the other could have dramatic effects on almost everything, as vacuums are an important part of life. Fundamental forces, gone. Elementary particles, shatters. Stars and galaxies? But how? Well, the change from one to the other is extremely dangerous, again. But how? I don't know. Well, again, it might not even be real, and it's very complicated, so I'm satisfied with this. They're a thing, perhaps, and they're dangerous, perhaps, so watch out, perhaps. Okay, who put George Bush in charge of the astrology class? Now, when we learn about the universe, and especially our solar system, we're reminded that we are really not that impressive. I mean, you could place the solar system pretty much anywhere in space, and us humans would have evolved the exact same. Yet, apparently, this might not be that true after all. What if the solar system has an important place in our universe, where even light from the earlier days of the universe, the CMB, notices us? You see, just like how the axis of evil were three countries that were out to destroy American culture and values, the cosmological axis of evil were notable things where our solar system had an important key role in destroying our century-long belief that we were just floating around in a random pitch in space. First is the CMB, a kind of baby picture of the universe, which is just light that has been around since the dawn of time. Literally. Apparently, the CMB is colder above the solar system and warm below the solar system. If the planets and galaxies of our universe are just placed randomly, then why does our solar system affect one of the oldest things in the universe? Along with that, the temperature across the sky, the monopole, also had a strange little thing in it. As it is cut up in different spheres, they should all ignore Earth and the solar system, as it should focus randomly on different parts of the universe. Yet, again, the quadruple pole and the octopole align with the solar system. These 2 points makes a kind of axis focused on Earth, the axis of evil, or maybe it's just random, who knows. But even then, we've always learned that we are just another speck of light in the black void. But did science just contradict itself? And are we more important than we think? Maybe we are the center of the universe, or maybe we're just a bit nosy. Now this is some rather deep shit, man, we're getting ourselves into. But thinking about it, it's kind of fun that no matter how far down or how far up we go in size, there always are some rather fun similarities. Quarks go around each other, kind of. Electrons go around nucleus, the planets go around the solar system or the sun, the solar system go around the supermassive black hole in the middle, and who knows what's going on at the higher or lower levels. But what if these patterns continue forever? What if our universe is all just a ball going around another big ball that might be that universe's version of an atom, for example? We can't see that high, so it might be possible. It might be possible that our universe is simply a fundamental particle. Again, it could also just go down. What if the quark in your hydrogen atom in your body has a whole universe inside of it? Does it go on forever, up and down? This is another unprovable and unbreakable theory, since we simply can't see that high or low in our universe. But it might just be a thing when you think about how many layers of beings there already are when you change in size. What might also be fun is that power trip you get when you try and zoom out in your head from your room to the solar system, to the Milky Way, to the galaxy cluster, to the universe at large, to the extended universe, all the way out to the neutron we might all just be, to the atom in that other world we can't see, and more and more. Man, we are so small, aren't we? Yet I am still average height, alright? I'm average. I'm average. Shut up. Oh my, Alice, where did I put my pocket watch again? So yes, since black holes are a weird phenomenon, we don't really know a lot about them. We don't really know how they work because we can't really get too close to them. Yet they would capture us and we would be forced to experience their whatever they are without being able to tell others because we would die. The thing about black holes is that they pull matter together and make a dense being which is as dense as you can imagine, and then even more. This is actually so powerful that it affects time. It makes it slower and suddenly it goes backwards. The pure density of the black hole, which is beyond massive, bends everything including time. So if one of us volunteered to go down the black rabbit hole, we might not survive, since the massive hole would just, kill us. If it was a wormhole, which is just two black holes connected through space, we might be able to go back in time. In the end, the physics says that it would be able to bend time, and again, go back in time, which is in itself is a huge paradox. Even thinking about how it functions would only lead to more weird things, which would even become so weird that time travel becomes a thing, which would then break time and space, so don't think too much about it, I guess. Now, having gone through all of these different areas of space and time, from the quantum level to our level, from the smallest speck of life to the largest known to man, we might feel unimportant. We are but a speck of life trying to live life. All we do is almost fruitless compared to the reality that is the hugeness and vastness of space. Yet maybe size isn't the thing we should be focusing on right now. Since we have taken a look at the more philosophical parts of nature, along with the hard mathematical and scientific parts of life, a kind of pattern emerges which should send some familiar, but not as familiar as they perhaps should be, signals. Now, looking at space-time, no matter how convoluted it might be for some of us, we see that it is simply matter in space moving according to mathematical equations and the allowance of nature. Looking at the Boltzmann brain, we can see that it's more or less the same. It's a sentient, non-existing being that has been made by the laws of science and by the use of mathematics. These instances are examples of beings that react to mathematical and scientific information for a living, which therefore makes them work like they do. In reality, they might as well just be making homework for a living, as that is all they do for eternity, react and progress a mathematical equation. But to which end does this reacting to information really end? I mean, isn't everything just a result of mathematical and scientific blunders? Come to that, we humans also react to science and information. I mean, all we do is our brain saying that we should or should not do certain things because it is wired to survive and live a certain way. And where does this gathering of information actually end? I mean, every little speck of life, even how civilized we might be, is a reaction to a primitive will to survive and expand the group. And if that is the case, then we aren't that different from the cow in the field, living because its brain is wired to do so, which then isn't that different from the tree growing, the asteroid in space, the Boltzmann brain, and so on. Maybe there really is no end to this information gathering. We know that everything is just information gathering, but to what extent? Is this video even happening? Or is it just our brain thinking it is there? as it reacts to information from our ears, eyes, and other senses. Does reality even exist, or is it just a figment of our imagination, while the real reality might just be numbers and equations? A huge mathematical question answering itself. You might look around and think that each and every person is a sentient and self-controlling being, but in reality, isn't everyone and everything just a matter reacting to information? Are we different from the stars in the sky, the faraway rock, and the flying comet? Aren't we just a result of mathematical and scientific equations? And aren't you just another result of science? Nothing more. Hello everyone, Dane here. I usually don't do outros because I don't think they're that useful, but just now I think they are. First off, good video, right? Spooky and all that. It took a bit too long, you know, vacation and all that, and procrastination, but who cares? Anyways, I'm here to talk about a special something, the future. You see, this February I'll be joining the armed forces, you know, the military, where I'll be for some 4 months, which means I'll be locked in a different city pretty much the entire of the week, except for the weekends, which will be the only times I can actually edit videos, which means, even though it's already pretty slow with making videos, you know, between a month and more, in the future, it'll have to be even longer. So watch out for that. I might make other kinds of videos, either shorter or different, but I'll try and keep the channel alive as much as possible. And again, it's only 4 months. I'll be back to normal after that, but you know, still, it gotta be said. For 4 months, this channel gotta be different. So this might be the last Iceberg child video you'll see for a while. You know, it is a real or OG one, but you know, just that. Didn't just have to say that. That's the thing I had to on my mind, on my heart, and now it's in the video. So now the video is actually over. So you can leave now. Wait, no, don't. That costs money. So just look here for a minute. Look. All right, cool.